of doubly reinforced beam, wherein we are provided with a question: design a rectangular beam of section 230 mm by 600 mm of effective span 6 meter. Effective cover for reinforcement should be kept as 50 mm. Imposed load on the beam is 40 kN per meter, and by using the M20 concrete and Fe415 steel. So from this question we have deducted the given data, which is B is nothing but 0.23 meter or 230 mm, and depth is given as 600 mm or 0.6 meter, and then small d, as we have as it is mentioned here, we have to take the effective cover as 50 mm, so it will be eventually 0.55 meter or 550 mm, and then small the d dash is 0.05, that is nothing but the effective cover, which is 50 mm. FCK is given as 20 Newton per mm square, and Fy is given as 415 Newton per mm square. Now we have to calculate the dead load. We have to carry out the load calculations. So first thing is we have to calculate the dead load. As we know, dead load is nothing but the area into density of concrete. So area is again breadth into depth of the breadth into size of the beam, which is equal to 0.23 meter, which is B, into capital D, which is 0.6 meter, into the depth, the density of concrete is 25 mm, 25. So we will multiply this, get the value of 3.45 kN per meter, and then the imposed load is given to us, which is 40 kN. Now we have to calculate the total load. So total load is nothing but the summation of this dead load plus the imposed load. So we have 43.45 kN per meter. Now factored load is nothing but the we have to multiply the total load with the factor of safety, which is 1.5 into the total load. 1.5 into total 1.5 into total load. So let us do that. 1.5 multiplied by the total load is here. So this is the factored load, which is nothing but WU. Now let us calculate the design moment. The formula for design moment, input the values first, equal to sign. The WU value is nothing but factored load into L effective square, which is nothing but this 6 meter raised to 2 divided by 8. So this is 293.29 kilonewton meter. Then similarly we have to calculate the design shear. The formula of design shear is WU into L effective divided by 2. So let us input the values here. So the WU is this one into L effective is nothing but 6 raised to 2 L effective divided by 2. So we have obtained the value of 195.525 kilonewton. Similarly, we have to calculate the value of the MU limit, which is nothing but 0.138 FCK BD square for so equal to 0.138 into FCK. We have the value of 20 Newton per mm square into 0.138 FCK BD square. So B is in this one, and D is your small d raised to 2 into multiplied by 1000. So because we have FCK in terms of Newton per mm square, if we convert it into kilonewton per meter square, then we have to multiply it by a factor of the conversion factor of 1000 or 10 raised to 3. So we will get the value of 192.027 kilonewton meter. So as you can clearly see here, the design movement is greater than limiting moment. Mu is greater than mu lim. So therefore it is a doubly reinforced section. We have to design it for a doubly reinforced section. Now to go further, we have to calculate the XU limit, which is nothing but 0.48 into D. So let us calculate that value, equal to again 0.48 multiplied by the value of D, which is given over here, which is 264 mm. Now we have to calculate the value of AST. So the formula of AST, we have to calculate first the value of AST1, and the formula is given here 0.36 FCKB into XU limit divided by, so let us input the values here, equal to 0.36 into FCK is 20 Newton per mm square, FCK into B is here 230 into XU limit we have calculated here. So let me put a bracket to this so that we avoid the confusion, and then divided by 0.87 into Fy is here. So if we add all this, then we get the value of 1210 mm square. Okay, AST1 we have calculated successfully. Now we need to go for the calculation of AST2. So for that, what we have to do is we have to calculate mu minus mu lim. So basically it's a straightforward thing. So mu is here minus mu lim. So the value is 101 kilonewton meter. Then we have to, as we know, lever arm is nothing but D minus D dash. Lever arm is nothing but D minus, which is nothing but 550 minus 50, which is 500, represented in terms of mm. Then the AST2, we have to calculate the AST2 by using this formula, mu minus mu lim divided by 0.87 into Fy into lever arm, which is Z, we have calculated over here. So mu minus mu lim we have already calculated. So let me put an equal to sign here, equal to this divided by bracket 0.87 into Fy is again 415 into lever arm is this value. So here we have to convert the kilonewton meter into Newton mm. So for that we have to multiply it by, so again kilonewton is raised to 6. So we have obtained the value of 560 mm square. Then the total AST is nothing but the summation of AST1 and AST2. So let us go further, let us calculate that total AST, this plus the AST2 is this value. So we have obtained 1771.79 mm square. Now total AST we have calculated. We have to find the ASC. area of steel in compression zone. So for that we have to calculate the epsilon SC, which is nothing but given by the formula 0.0035 into bracket XU limit minus D dash divided by XU limit. So let us go in, let us calculate the value here. 0.0035 into bracket XU limit is nothing but, we have calculated the value of XU limit minus D dash is nothing but, again D dash is given to us, which is 50 mm divided by XU limit So we have obtained the value of epsilon SC. Then from the by using this value and from the stress strain curve, we can find the value of FSC, which we can find from the SP16. So the value of FSC we have found is 352 Newton per mm square. Then we have to calculate the area ASC. So for that we have this formula 0.87 into Fy into AST2 divided by FSU. So let us go further. Let us go ahead and put the values here. So Fy is 415 into AST2 is this value divided by FSC we have calculated here. So we have obtained the value of ASC as 575 mm square. Now this is the value of this is the area of steel in compression zone. Now what we can do is we can assume we can provide 6 bars of 20 mm in tension zone so we can provide 6 bars of 20 mm dia in tension zone. So if we calculate, then the AST provided will be 1885 mm square, 1885 mm square, which you can see is greater than the AST, total AST required. AST required is total AST required is 1771.79 square, and the AST provided will be 1885 mm square. So similarly, what we can do, we can provide two bars of 20 mm in compression zone. So ASC provided will be 628 mm square, which is greater than the ASC required 575 mm square.